All right. Today we have Jakub Zavrel, founder and CEO at Zeta Alpha. And based on their website, it's the best neural discovery platform for AI and beyond. It uses state-of-the-art neural search to improve how you and your team discover, organize, and share knowledge. And full disclosure, I am an avid user of their I guess it's like their it's not exactly their product, but it's a place where prospective researchers can play around with some of the capabilities, right? Is that how you would describe what I'm using?
Yeah, thanks for having me on your show. So indeed, we thought when we start kind of discovering how to build enterprise search system using neural search and large language model, why not start with something we know very well, like the AI and data science space? And essentially, we have this problem. We know it very well, right? There's so much new stuff coming out, so we decided why not start with organizing that, and from there we can grow to organize all kinds of stuff and connect people and knowledge more in general.
And it's a way for you to kind of experiment and play around with some of the new techniques, right? So, and also see how people are responding to certain user interface design changes.
Absolutely, but it's really also very practical for ourselves and many in the AI and data science space. To keep track of new papers, to make sense of the fast pace of developments, discover trends, and just not have to go through the archive feed manually every day.
So we'll talk a lot about Zeta Alpha throughout the course of this episode, but one of the first things I wanted to bring up is this post you had a few weeks ago on the 100 most cited AI papers in 2022. Which actually has some interesting and surprising results in there. But, I mean, we live in a very interesting time because what made it viral was the comparison between China and the US, right?
And
so that alone kind of really blew it up. Yeah.
And so if you talk about, research in AI, there's a lot of volume, obviously. And we got kind of accused a couple of times that, volume is not impact, right?
Oh, by the way, before you proceed, Jakub, so let's describe the data set for this 100 most cited AI papers in detail. So first of all, what constitutes an AI paper? And what are the data sources that you used?
Yeah, so we collect all of the sort of fast-paced literature, archive, conferences, open publications, GitHub, Hugging Face, etc.
But how would you define a paper?
A paper is essentially everything that looks like a paper. So it has a title and some content, and it's about AI and data science broadly defined. So it ranges from very theoretical to very engineering and applied oriented stuff.
So would a blog post with a title, an abstract, and some references, would that be a paper?
Yeah, well, that's definitely stuff that we index in our platform, but it's not stuff that we took into account in compiling that top 100. So for that top 100, we actually looked a little bit stricter on kind of really research papers and citations, which is kind of a very classical measure of impact. So if you look at papers that came out 2022. Some of them already collected a lot of citations, but some of them are not in the gray literature. Some of them are in like the Natures and Science, and so we expanded a little bit our usual scope, and we really looked at everything that we could find and that is AI related.
So then, when you say AI related, if you look at archive is massive. It has math, physics, social sciences. Yeah. Some of those papers use machine learning, deep learning, and AI. So are they considered AI papers for the purposes of that post?
Not all of them. Not all of them. No. So we do kind of, it's a subjective, right? What is an AI paper? But we took it pretty broadly, but still focusing on like NLP, computer vision, robotics, reinforcement learning, theoretical machine learning, a little bit of statistics, speech processing, and then kind of the classical sub areas of AI.
So basically you went into archive and took certain tags or areas in archive.
Yeah.
And if you label your paper there, then you're part of the study. And then you also took papers that were submitted in conferences. So as far as the conference papers, do they have to be accepted to be in this study that you conducted?
Well, they have to be cited. So we looked primarily at citations. We took all kinds of detours to find papers that were actually frequently cited. So the archive papers actually collect citation statistics, right? There are also papers outside of that corpus which are cited. So if they show up in the citation statistics, we looked closely whether they would kind of qualify as AI papers.
And then as far as time, this paper has to have a timestamp of January 1 to December 31, 2022.
Exactly. Yeah.
And then, so let's go through the findings. So obviously, as I alluded to, the thing that made it viral was the comparison between China and the US. So you guys had a very provocative social media post. I forget exactly the phrasing around US has not completely lost yet, or something like that.
No, I don't think so. So if you look at pure volume, and there are studies that other studies that have looked at pure publication volume, and they have concluded that China has surpassed the US in AI publications already a long time ago.
Oh, before you proceed further, how do we assign countries for this?
So basically, we look at the institution. So we look at the affiliation of the author. We don't look at their kind of, we don't see their passport or where they currently living. We look at the affiliation. So something like Tsinghua University is China, or Huawei, even though some of their labs might be in Europe. So it's kind of the location of the headquarters of the organization.
But the top line here is that China and the US are in a league of their own, right?
Yeah, they're definitely like clear number one and number two, even whether you look at volume or whether you look at impact in terms of citations. But if you look at impact, the difference is actually larger. US dominates more, but China is a clear number two. So definitely very strong contributions from Chinese institutions.
And then if you kind of look at the individual European countries and factor in the size of the population, what does that tell you?
Well, so we did aggregate it and add up all the European countries and all the Asian countries, and actually Asia and Europe are kind of tied, and clearly behind US in the top 100 representation, but are kind of tied. But obviously Europe is a lot of small countries, so we see France and Germany and UK contributing pretty strongly, although UK, a large part of that is actually DeepMind in a league of its own. And then other countries like Switzerland, Denmark, and Netherlands figure pretty strongly also in the European ranking.
Speaking of DeepMind, actually the number one paper from last year was Alphafold, right?
That's right. Yeah.
And so so in the post, you guys didn't really go through in detail the findings in terms of topics and trends from this particular data set. So are there any things that you want to share with us from this data set that didn't make it through the post as far as a top line? So what stood out to you? Was reinforcement learning back? Were graph neural networks back?
So we did. It's not. I think it's not in the blog post. So this is a unique peek behind the scenes. But the top single topic was multimodal models. So models that do language and vision, or that do image generation based on text prompts. This was a very strong topic for last year.
So this would include things like applications like DALL-E or Stable Diffusion, right?
DALL-E, Imagen, Party, make
Clip.
a video, all those kinds of things. But if you look at the total, everywhere large language models are involved.
Right.
And the language model topic kind of splits into a couple areas. And I think the one that really stands out for last year is kind of the discovery of reasoning in large language models. So you've seen kind of chain of thought prompting coming into play, and then people discovered if you prompt in a specific way, these models can exhibit quite a lot of amazing reasoning at scale, right? The large models, and including mathematical reasoning. And well, just recently, of course, GPT-4 came out, and that's kind of tops that development. And I think we started last year with a situation where a lot of people thought large language models predict the next word. They can predict it very accurately, but they can predict the next word. And then people got into prompting them and discovering that if you prompt them the right way, they can do a lot more, like chain of thought or reasoning. But then with the release of ChatGPT, this completely turned around. So you see that all of this knowledge, which has been acquired by large language models to predict the next word with a simple kind of reinforcement learning from human feedback, can be turned into very powerful instruction following. And so I think kind of exiting the year, you see that basically the Instruct GPT paper is picking up a lot of impact, and that's kind of where we are today.
So I recently wrote a post where I said, so teams should start thinking of three things in terms of customizing these models. There's fine tuning, there's prompt engineering, and then this reinforcement learning with
human instruction tuning.
Human feedback, right? So in terms of this chain of thought, so in general, Jakub, what is the delay between when something like that starts getting written a lot about in research? When do we start seeing it in industry?
Well, that used to be years, but now it went to like months, and
weeks.
I think the time lapse between the Instruct GPT paper, which kind of made that point, it came out in February last year, and by end of November we had the ChatGPT release, which I would call pretty like strong product in terms of industry impact. So it's within a year.
So we're recording this on the day when Google is now kind of letting people sign up for Bard. So are there any things that are Google specific from that body of papers, from the top papers from last year, that caught your eye?
Well, actually, a lot of the papers about large language model reasoning were all from Google.
And explain this topic to our listeners who may not be following this closely. What do you mean by large language model reasoning?
So reasoning is I would call when you give a prompt, a question, which actually requires a number of intermediate steps to form a logical conclusion. So this could be making some intermediate calculations or making some deductive steps on properties of objects, combining information from multiple sources, and then kind of putting that together. And the chain of thought paper really started this, saying like, if you think step by step, and then the language model starts to generate this kind of intermediate steps, which are kind of quite obvious from the sense of predictive next word generation. But then because it has access to that sort of buffer of its own scratchpad thoughts that it just generated, it's actually able to jump in accuracy on these kind of reasoning-like tasks by a factor of magnitude.
So the Google paper that you are referring to, when did that come out?
I think that came out somewhere March, April last year.
And that then resulted into how many people were inspired by that paper?
So I think of the top 100 papers, there was about 10 papers in the top 100 dealing with large language model reasoning. So about 10% of that.
Wow.
And there's a whole cottage industry of these papers. If you look sort of at the larger volume of papers, it's just hundreds and growing.
So anything else that stood out from that data set from 2022?
Well, there's a couple of things which are maybe not so much in the limelight of,
Yeah, that's what we're looking for here.
Catching the eye of the press, but there's obviously a lot of people working with these transformer models in completely different domains than vision and text. So think of things like generating molecules or proteins, right? Alphafold was the most cited
number one paper, yeah.
Yeah, and Collabfold, which is kind of a similar piece of work, number 2.
Yeah. But basically, a common thread here, Jakub, is transformers.
Oh, absolutely. Everybody is using transformers these days. And you see that also going into code generation, which is language-like, but also into fields where you would completely not expect it, like reinforcement learning, playing multi-agent games, and even robotics, right? There were papers which use kind of the common sense knowledge encoded in large language models to actually drive planning and goal-seeking behavior and kind of common sense reasoning in real embodied agents, robots.
What's your sense of transformers and computer vision? Because there it seems like CNNs are still the most popular thing, right? So what's your sense of transformers as you know, like you said, in language, it's pretty much transformers everywhere, right? So, but that's not the case necessarily in computer vision, right?
So I'm not a computer vision expert myself, but there was this paper, a ConvNet for the 2020s, published by a group from Meta, which made quite a lot of impact, which kind of proved that, you know, if you do all the tricks from transformers, they can still beat transformers on ConvNets can still beat transformers on computer vision. Kind of if you squeeze out every last bit of trickery from the training process and the architecture and all that. But I think the thing is that until quite recently, transformers for vision were not really scaled up. So you didn't get these kind of scaling law effects. They were still pretty small models in the sort of lower billion parameter. And recently a paper came out from Mustafa Degani in a group at Google that kind of scaled up vision transformers to like, I think 22 billion parameters. And that's also the submodel used in the more recent multimodal Palm-E model. And yeah, I think transformers will eventually win it if you have enough data and if you're like, you know, and enough compute reserves. Obviously, if you want to do computer vision on your mobile phone, it's still a bit tricky using transformers.
So I noticed recently, Jakub, there are now transformer models in computer vision in the 10 to 20 billion range. Is that correct?
Yeah. Yeah, that's the paper that I was mentioning by Mustafa Degani. Yeah.
And what has been the impact of that paper, as far as you can tell?
Well, again, I'm not a computer vision expert, but I think it was kind of hard to scale up to like from an engineering perspective to scale up to that level. But now that that's kind of accomplished, I think we'll see a lot more very large computer vision models. And also multimodal, right? They do both computer. I mean, GPT-4 is a multimodal model. Nobody knows the exact architecture because they haven't published the details, and people were upset about that in the research community. But I think that's probably not a very small model either.
Right. So, in terms of the multimodal papers, what sorts of applications might you imagine coming out of this very active research? So we've seen kind of the stable diffusion kind of thing. So do you imagine, in the future, search will be multimodal itself, right? So.
Yeah, well, if you talk about neural search, which is our specialty that we work on a lot at Zeta Alpha, one of the amazing properties, if you compare it to keyword search, is obviously that in the neural embedding space, it doesn't matter what your objects are, right? You can embed text, you can embed images, and you can align those representations to do multimodal retrieval. That was not really hard before neural search. And with these very large vision models and these multimodal models, I think you're seeing going beyond that, going into reasoning about images, right? Reasoning about tasks that require putting together multiple images. You're seeing question answering from images, like what's going on in this picture. And ultimately, I think you're seeing a move towards embodied agents. So with Palm E, that's an example of that, where you really have kind of language, vision, and robotics combined in a single model that allows the agent to basically deal with its environment, be perceiving and acting in a dynamic physical environment.
So one of my pet peeves is that not enough people work on audio and speech. But then last year, I mean, not last year, but recently, over the last year, I would say, right? So a couple of interesting things there. One is Whisper from Meta, right? Yeah. And then recently, I think just the last week or so, Google announced this universal speech model.
Yeah.
Right. So I don't know if that's open source. But the point is, there's also listeners out there, don't sleep on audio. While everyone else is chasing text and vision, there might be opportunities to build applications and companies in audio, right?
And the combination, right? Like if you have really good speech recognition in multilingual in many of the world's languages, we can have this chat here on video, and you can do the transcription and then summarize using GPT. And there are people who've put together prototypes for that, and in 1 minute you have a complete summary of this video. It's amazing.
So I actually advise a speech company that can do incredible real-time, basically voice synthesis, right? So in real time, I mean, it would be like us right now talking on Zoom, and you wouldn't even notice that I'm talking to you in a British accent, right? So suddenly, miraculously, right? So there's things like that. By the way, Jakub, so one of the things that you mentioned earlier are the scaling laws, which are interesting in the language. I think people started thinking more closely again about scaling laws with that DeepMind Chinchilla paper, right? Where basically they showed that by training with, I don't know, 10 times more data, you can get a smaller model, and then that smaller model might be as accurate as the larger model. So it turns out these large models are severely undertrained, right?
Right. Yeah, and you can get just a lot more inference efficiency and quality by training a smaller model longer. So again, with GPT-4, we don't know the size of the model, so it's kind of speculated that it is kind of a trillion, or who knows, many trillions of parameter model. But I'm sure the people from OpenAI have also read the Chinchilla paper and also realized that this fact about data efficiency and scaling laws in terms of properly saturating the training process.
And to a large extent, Meta's Llama follows along these lines, right?
Exactly, yeah. And I obviously I think it's really important for the community that open source alternatives exist. So I'm a big fan of Meta's open source policy. That they're really releasing all these things out there. And as you saw recently, people from Stanford, you took Llama as the base model and then did instruction tuning on it with data actually generated by GPT, right? Kind of synthetic data. I think that's a topic I want to come back a little bit next. But with synthetic data, you can basically fine-tune this Llama model to follow instructions, and supposedly it's about as good as a much larger model like GPT-3 was.
My only request to these researchers is please use a different license.
That's right. That's right.
Otherwise, I guess it's better than nothing, right? So other researchers can use it, but for entrepreneurs, licenses matter. Apache
2 or MIT license is better to swallow. Absolutely.
So you had a request to talk about synthetic data. So go.
Yeah. So obviously, distillation has been known for a long time, right? It distill the outputs of a larger model into a smaller model and kind of train it also to saturation. So I think these topics have a lot to do with each other, data efficiency and distillation. But this has really been kind of in the field that we work, information retrieval, right? Search, neural search, has been one of the topics that we have been working on, and many others as well. And that has really led to a substantial breakthrough. So there was this kind of notion that neural retrieval models, if you do kind of a dense retrieval, right, that it was good for in-domain, like if you train on, let's say, an MS Marco data set, and you can get a very good dense retrieval model on that. But these models would kind of fail out of domain. And there was the Beer benchmark, which collected around, I think, 14.
So can you, Jakub, can you describe more specifically the types of tasks and the problem that?
Yeah, well, so there are, of course, different kind of perspective on search, right? But usually it's some kind of question and a document, or question and a passage, and obviously there are others like find a counterexample, or find a supporting argument, or
but most people who use search right now don't even have that experience. They have a list of ranked results with snippets, right?
Yeah. So that's still like in this benchmarking of retrieval systems, that's still kind of the setting, right? So you want to have your good documents as high as possible in the ranked list, in the top 10 or the top 1, and this is then measured. And so these dense retrieval models didn't do so well when they were taken from when you take a model which is trained, for example, on web search, and you apply it to legal documents or medical documents, or document similarity. But now with this synthetic data, and that's a method that we have pioneered with the team from Rodrigo Nogueira in Brazil, you can generate synthetic data with large language models in a kind of zero-shot or few-shot fashion.
So in working with that example, you have a model trained on web search, you create synthetic legal data.
Yeah, And then for your legal data, you obviously don't have like hundreds of thousands of relevance judgments that you can train on. Like you don't have supervision, right? So you just have the documents. But then with the in-parse method, what we do is basically take these documents or passages from these documents and ask large language models to generate synthetic questions for those documents. And because we know which document was generated from, we now have a pair of a document and a question for which that document is relevant. And now we can kind of fine-tune these retrieval models for out-of-domain performance and get as good performance or even better than a very strong retrieval model like BM25 or even a cross-encoder re-ranker, which can generalize very well.
By the way, so going back to your description there of taking model trained on web data and mapping it to legal search, I think our listeners might wonder, well, traditionally the search pipeline is you start with the documents you're searching, you index and crawl those documents, right? So what does this other domain of web have to do with legal? In other words, I take my search tools, I should point it directly to what I'm searching, right?
Yeah, so for this neural search to work, you obviously need like a vector representation of your document, right? And a pure language model, like a BERT style representation, is not good enough for actually like having documents which are similar or queries and documents which are relevant to each other be close together in that space. So for this, you fine-tune these representations from large language models on, for example, on web search, right?
So it's basically the embeddings themselves that you get from general data need to be fine-tuned for legal data.
For the search task. First, you have to fine-tune them for the search task,
right?
But then within the domain, there's a lot of very domain-specific vocabulary and patterns that are important, right? Like if you do a legal retrieval, maybe all of your documents matter, not just the top one. So
the workflow starts with I have general embeddings, BERT style embeddings.
Yeah.
Then I fine-tune those embeddings for legal documents.
No, first you fine-tune them on something that you have a lot of data for, like web search.
Web search, okay.
Yeah.
And then
you specialize it, you fine-tune it again, but now on synthetic data from your domain that you have generated yourself.
Okay. But then that second fine-tuning, does that require humans?
No, because those in-domain synthetic examples are generated using, let's say, GPT or Llama or one of those models.
But you don't even use some humans to at least kind of give you the equivalent of RHLF, right? So up, down. So okay, so let's practice with the search engine and fine-tune it further.
Just a very tiny bit. So what you do is you do this in a few shot setting. So you give like 3 examples. So you give GPT 3 examples. This is a passage from my domain. This is the answer. This is another passage from my domain. This is the answer to that. We typically give 3 examples. So it's 3 shot. And then you generate for all the documents in your collection or a substantial set of them, maybe if you 10,000 or 100,000 documents, you generate kind of extrapolate from those 3 examples without human supervision.
So you're in the space where you're trying to sell search solutions to enterprises, right?
Right.
So are you starting to have conversations along the lines of, hey, Jakub, this is great, but I started using ChatGPT last week. Can we have a ChatGPT-like user interface? Is that starting to happen?
That's absolutely kind of the thing. So there's 2 things. GPT by itself, large language models, generative large language models, they make stuff up, right?
Yeah,
And hallucination. And unless you ground their output in knowledge which is retrieved from a search engine, you cannot tell whether it's hallucinating or actually retrieving correct information from its training data, right?
But going back to my question, are people putting pressure on you to have a solution that mimics this kind of user experience?
Yeah, so people find it extremely appealing to have a direct answer to their question, to not have to go through 10 blue links, right? To not have to read all the documents, to have GPT summarize and kind of point out the essential key facts and the actual answer to your question. But unless it has a retrieval component, it's essentially useless.
So
right?
what will be the hybrid UX in the future? Will it be a chat interface with citations? So what would that look like?
Yeah, that's kind of what it's converging to right now, because on the one hand you need to retrieve the facts, but on the other hand you need to give the users a traceable reference where they can, like, no search system, no question answering system will be 100% correct. But if you can trace the answer back to some actual passage in a document that a human wrote, then you can kind of use it, right? And you can fact check those answers.
So, so using your intuition, is prompt engineering here to stay? So in other words, there will people who will be master prompters and skilled prompters, or is this a kind of temporary aberration? As the models get better, we can all just prompt and we'll all get the same results.
So I think prompt
this
engineering...
is a difficult question. Sorry about that.
So I mean, it's always a mix, right? And I think prompt engineering was in everybody's focus sort of mid last year, when these models were fine-tuned on instructions. Basically, prompt engineering got to be less important, because with a simple instruction and zero examples, right, you can already get pretty good results. It's following your instruction, so it's no longer predicting the next word. It's actually using the representations that it has to find a response to your instruction. But still, with different instructions, you get different results, right? So it's like with humans, the words that you choose remain important. So I think, it's not a kind of a new engineering discipline, but I think it's still, essentially building software system using these large language models has become writing text, right? And writing effective text is a human skill, which is has always been very valuable, and is also very valuable in that context. And it's a lot less precise than, let's say, traditional software engineering.
So based on your since you track the research literature very closely, so are a lot of the things we talk about, developments in large language models, they're very kind of English, there's a bias towards English, right? So in other words, if you're in a non-English language, the developments might be less. Just because the data sets are fewer and whatever, right? So less research attentions, less benchmarks. And
that's what you would think. But the first thing I tried when I tried ChatGPT, and now also GPT-4, is tried in any of the languages, European languages that I kind of master, and it's not what you would think, actually. So Dutch is a small kind of language. It's not under-resourced, but it's still a small language. GPT knows Dutch pretty well.
So one of the things that our listeners have heard me talk about is, I think that right now we're in a place where when you look at these large language models, there's only a handful of outfits who actually regularly produce them at a regular cadence. But I speculate, and not just me, a lot of people speculate that moving forward, a lot of companies will actually want to have their own large language model for a variety of reasons, right? So one, I may not be comfortable sending data through an API. I may not be allowed to do that. I may want to move faster than my competitors. If we're all using the same API, then I can't move as fast. There might be security reasons and whatever. So I think there will be a certain amount of decentralization. So decentralized custom foundation language models. So what do you think? So for example, if I'm a European bank or a European healthcare company, will I want to just call out to an API and send all my data? And by the way, we're recording this on the day where yesterday seems like something happened to Chat GPT where it went down and supposedly people could see other people's history. Right? Yeah.
Well, I think by no means we want, as a society, as a global technology community, a monopoly of one party, right?
And by the way, before you continue there, Jakub, so another trend in our favor is what we talked about earlier, which is basically the scaling laws seem to indicate that maybe these models can get a little smaller, more manageable, right?
Sure, they will become more efficient, but still, the scaling laws by and large hold, right? So you will get higher quality at a higher scale. More compute is more intelligence.
But you might be able to get by with a large model if you saturate the training, right?
So I think the situation that I see right now is this. So NLP has radically changed, right? Where in even 1 or 2 years ago, you needed to build specialized models for everything. Right now, prototyping has become essentially zero effort, right? You can use a large language model, the largest one that there is, the best one, to prototype your use case. And then when you have that prototype ready, you need to think, of course, how am I going to deploy this in production? What's my risk? What's my cost? What's my engineering footprint? What's my privacy compliance? What's my competitive situation? And based on that assessment, you can come to the conclusion that deploying a somewhat less powerful, somewhat smaller model, but maybe go a little bit back in time and fine-tune it a little bit, or make a very specific prompt that works really well for your use case, that is indeed a kind of a competitive solution for what you're trying to do. But I think the prototyping will happen not at the small scale with less capable models, but the prototyping will happen with the most capable models, and the open source and the other, competing vendors and your own internal developments will kind of follow that.
And we're also very early in the sense that as you mentioned, we're starting to see more and more artifacts in the open source, right? So starter models, some common data sets that you can use to get going on your own. It's hard to imagine a world where people will just punt and say, okay, I'll just heavily rely on crown jewels, my IP, my data. I'll just farm it. I'll just send it over to someone else, right?
True, but the same thing was said about cloud computing, and eventually all IT departments in the world surrendered, given some security guarantees, given redundancy plans, given kind of multi-cloud deployments. So if you're relying heavily on OpenAI, you might want to open an account with one of their competitors as well. And if OpenAI goes down, you auto switch to Cohere or whatever. Or
cloud to computing, I'm not contributing to the model of I'm just using SageMaker. I'm not contributing to you know what I mean. So this is different than contributing to a centralized model. So So maybe I still rely on the provider, but maybe there's a certain amount of decentralization, right? So I have a decentralized custom model just for me, right? So
people trust cloud providers like Amazon or Google or Azure because they have this immense technological capability to safeguard your data and make sure.
well, no, it's not data. It's the data is contributing to the improving something that everyone else.
Right.
This is a very different paradigm than just okay, I'm using my data, I'm using your database, I'm using your machine learning algorithm to process my data, but a machine learning framework, not model, right? So so
so I think these providers will have to provide safety guarantees, but also guarantees of not kind of leveraging your data. I mean, every software vendor has to kind of have a discussion with their customers. Are you using my data to benefit my competitors, right? And then you put it in the contract that you don't do that.
Because I think that it's becoming clear that the models right now from one group to another, they're pretty much interchangeable, maybe. And then over time, maybe there will be open source manifestations of these interchangeable models. So yes, so maybe you don't have the most cutting edge, but for your own legal search application, this interchangeable open source model is fine.
Yeah, no, I completely agree that can be an outcome of your internal policy. And it's a fair outcome, and certainly for some high risk application, you're seeing also that EU is and US are going to regulate a lot of high risk AI applications, including processing of privacy sensitive data or things like that. And you have to make an informed choice among these things. Point I just want to make is that at this moment, the quality difference is quite substantial. So
at this moment,
we don't want an open AI monopoly, but we're heading right into it right at this moment.
Well, I think among the large companies, there's going to be a lot of interchangeability, right? So Google will have a very fine model. OpenAI will have one, maybe Anthropic. I don't know, right? So there'll be a bunch of these, and then people are clever in terms of being able to reverse engineer.
Absolutely, yeah, and
some of these things,
again, kind of distill, right? So essentially, the Alpaca model was really interesting because they essentially reverse engineered the instruction tuning of GPT and applied that to instruction tune Llama, and in that sense, large language models are kind of vulnerable to stealing the intelligence that was acquired using very large investment on compute and putting that in a much smaller model.
By the way, so right now when we talk about a lot of these things, just because of where we are at this moment in time, we tend to think of this kind of cloud applications on the laptop, but we have these too. We have smartphones, right? So there might be a very adept model on your smartphone that works offline. And then, by the way, what does that do in terms of multimodality? Now I have location data. I land in Amsterdam. I have this really amazing travel assistant. I walk up to an address. I go, what's in this address? Right. So, and then it gives me all sorts of nice trivia. Right. So, and then I can interact with this. I can interact with this like a buddy. Right. So,
that's a very attractive vision, and especially if you think that you're sharing an enormous amount of information with your personal assistant, you might want to have that very secure and very private. And people are speculating why Apple hasn't released any large language models yet, right? And one of the aspects of that speculation is that they're actually working on something which is kind of privacy sensitive and maybe even on your mobile device, very personal.
Right. Yeah. So
by the way, Apple does not publish a lot of their things in the open literature. So
Yeah. I think Carlos Guestrin tried to change that, but now he left. He's at Stanford. Um, so yeah. So speaking of which, the Llama, right? So first Llama was released within a few weeks. Someone had it running on a laptop, then a Google Pixel phone, then a Raspberry Pi.
That's
You
right.
know?
But at 10 seconds per token. So it's kind of
Yeah.
improving.
Yeah. But still, it shows you that the ingenuity of people once
People are smart. Yeah.
once it's available and it's useful, right? So by the way, so here this is the massive difference between this and Web3 and crypto, right? Because with this, immediate utility is obvious, right?
Yeah, I was never a big crypto or Web3 believer.
Neither
And
was
I've
I.
been in AI for almost 30 years because I think the goal is quite clear there. Ingenuity of a determined and smart small group of engineers is something that gives unbelievable results. And you see that also that, massive companies like Google who have, thousands of researchers they have trouble shipping. So it is the hackers, the ingenious inventors, and small groups of engineers that usually make things happen.
Yeah, they're in kind of a difficult position because on the one hand, if they move fast, they get criticized, right, for not paying attention to alignment and responsible AI. If they move too slow, then they're cast as being too bureaucratic. But it's a very difficult position. And also they have their crown jewel is search ads, right?
Yeah. Well, so a lot of people tell us at Alpha that like, who are you to take this enterprise search thing on, right? There are much bigger companies investing much more in that, but that's really kind of the bet I'm making with Zeta Alpha is that small groups that are very dedicated and can push things out fast. They can maybe innovate in a better way than super large research department and multinational companies.
And the problem space is it's infrastructure, but it's very well defined and well known piece of infrastructure, right? So one of my pet peeves, as our listeners know, Jakub, is especially my friends out here in Silicon Valley have heard me complain multiple times about people always tend to build for their friends, so which means they build platforms and frameworks, and which is great, but then it's hard to build a company because your friends tend not to pay for anything because they're also engineers, right? Whereas there's actually a lot of opportunities in very targeted systems like enterprise search or applications, right? So cybersecurity or healthcare or whatever. I mean, as we opened this podcast by talking about the most popular paper, the most cited paper last year was Alphafold, right? So there's a lot of applications of everything we talked about in very specific domains, but the problem is most engineers don't think in terms of domains, right? They think in terms of I want to solve the problem for everyone, right? So
well, I think if you can solve a problem that you know really well and you can solve it for people that you have close contact with, your users, right? Essentially solving a problem means listening to users really well, and I think that's kind of a natural that you find the problems that are an itch that you need to scratch for yourself.
Yeah. But what I tell people is, look around you and look at all these huge market opportunities in different industries and domains, and then see if it's something you're interested in. Go chase it too, right? So not everyone needs to build a platform. There's only going to be a few platforms by definition.
Like it personally irks me endlessly that enterprise search is an unsolved problem,
Yeah.
and that everybody in the top 1,000 companies or small companies in the world agrees that their internal search sucks and that they cannot find anything, and the quality of the technology has to prove them wrong and has to
and
solve the problem.
this to me is an example of, you're building a piece of infrastructure that's very laser focused, right? So that people know they need and they will pay for.
Yeah, and so I think these large language models and neural search are really kind of a new window of opportunity to solve that problem. Because why is web search solved and enterprise search works so badly? Because you don't have millions of clicks in enterprise, you just have the content. And if now you have really powerful transformer models, large language models that understand the content really well, that's an enormous opportunity, because you can now solve it sort of from principles by looking at the content, connecting it to what people are actually interested in, and bridge that gap, which keyword search was not able to do.
So do you think that so in terms of enterprise search, so the is your focus primarily in the beginning? Obviously, it will be, if I'm a company, you'll give me tools to search my company's data, but over time you will also provide solutions for my company's customers. When my company's customers visit our website, they will also have better solutions. But initially, you'll focus on internal users, right?
I think the internal problem is the most interesting one and the most valuable one. But on the other hand, I don't really see a reason why employees in companies should use a different product to search their internal information, the information about their company in the media and the news around them, and anything on the internet they need to do their work. So I see kind of these different layers of information, from global to really personal and everything in between, coming together in the coming years.
So in terms of Zeta Alpha, so for our listeners who are intrigued and wanna learn more about Zeta Alpha, obviously there's the application I alluded to, which is the one that researchers like myself use. But are you folks ready to talk to companies to start using Zeta Alpha for enterprise?
Yeah, we're doing that right now. We're implementing tons of connectors to existing systems. If one would search your Slack, your Google Drive, your Confluence, your GitHub, all that kind of internal information. So you can try that right now.
Do you think over time you'll also point to the data warehouse, data lakehouse?
That's I know that's sort of big data is your lifelong passion, and obviously, if you talk about search, you're talking more about unstructured data.
Yeah.
If you talk about kind of data mining and data warehousing, you're talking more about structured data, right? But essentially, a lot of that structured data is also a mess. So now that we have very smart language models, I think the opportunity is there to more and more.
Can you embed? You can just
develop kind of.
Can you also use? Can you also use embeddings so I can ask questions about my data warehouse, data lakehouse?
It's coming. It's coming. Yeah, definitely. So tabular data is the next target for large language models, I think.
And with that, thank you, Jakub. This has been a fantastic conversation.
Thank you for having me.